Okay, now we learn the reaction of Grignard reagent with alkyl cyanides. What are alkyl cyanide or alkyl nitrile? Suppose I write C2H5Cn. This is ethyl cyanide. But if you are calling it as a nitrile, then you have to count all the carbon atoms in the chain. So this is propane nitrile. Is it clear? So this is having 3 carbon atoms, so you call it as propane nitrile. If you are calling it as a cyanide, you call it as ethyl cyanide. Now suppose I take CH3MgBr and treat it with C2H5Cn. Now remember C triple bond N. We have already seen that Grignard reagents always act on that carbon which is attached to a multiple bond with a more electronegative element. So this is the carbon on which it is going to act. You know CH3MgBr can be split into CH3 and MgBr. CH3 is the nucleophilic part, MgBr is the electrophilic part. So this nucleophile CH3 minus will give its electrons to this carbon, which we know is electrophilic in nature. We have already seen. Why is it electrophilic? Because one of the pi electrons will shift to nitrogen, giving it a negative charge, and this will have a positive charge. Okay, so this is an electrophilic carbon present here, to which this CH3 of the Grignard reagent will give its electron. So what are you going to get? C2H5 CCH3 double bond N MgBr. You are aware of this. MgBr will add across a double bond to the electronegative element. So this is what you are going to get. Okay. Now this will undergo hydrolysis. You know what happens. First step, we are using dry ether. Grignard reaction, first step is dry ether, second step is acid hydrolysis, H plus and H2O, acid hydrolysis. This portion will go away, remember, and you will get C2H5 CCH3 double bond O. Okay, and actually this will form NH3 and MgBr and OH. So what you are going to get is a ketone. From an alkyl cyanide, what will be formed? You are going to get a ketone when treated with Grignard reagent.